Okay, so this is the fourth sea-level vodcast here from Molecular Compounds. It's the last one for the sea-level work. I told you guys you'll be learning the first three of the 5 types of naming for inorganic compounds. In the first 2 lectures, we worked on binary compounds. In the in the third lecture, we learned ternary compounds with polyatomic ions. Now, here in the fourth sea-level lecture, you're going to learn how to name molecular compounds, and it's a snap compared to the others. So if you recall, molecular compounds are just made of nonmetals, and the smallest piece of a molecular compound is a molecule. And these can't be held together because of opposite charges, the way ionic compounds do. Their pluses and the minuses don't cancel out the same because of the patterns that we learned on the periodic table just don't hold. So we also can't use the charges to figure out how many of each atom there are. So we have to have another method. So with molecular compounds, the name tells you the number of the atoms. With ionic compounds, we had to use charges to figure out which one is which. With molecular compounds, we learn prefixes to tell you the exact number of each element present. So your prefixes are pretty simple. Okay, they're listed on your golden sheet. Mono, di, tri. 4 is tetra, not quad. Penta, hexa, not hepta. Okay. 7's hepta, not septa. Octa, nona, and deca. Okay. So watch out. Again, spelling counts. Don't call nona nano. That's a common mistake I see students make. So to write the name, you're going to write 2 words. You're going to write the prefix and the name of the element, and then the next prefix and the name with the "ide" ending. So this would be your first word, and then your second word would be, again, one of these prefixes, the name of the element with the "ide" ending. Okay, there's only one exception to worry about here. We don't write mono if there's only one of the first element. Okay, so we wouldn't use mono on the on this first word here. No mono. Okay, but you can use mono on the second word, as you'll see. And then also you want to watch your spelling. Okay, we tend not to have double vowels when writing the names. We don't go OA or OO. We drop one of the letters. So let's practice. N2O. All right. Nitrogen and oxygen. How many nitrogens do I have? I've got 2. So it's di-nitrogen. And I only have 1 oxygen. I've got this invisible 1 here. And so I would say monoxide. Again, I dropped that double O. 1 means mono, and then oxygen becomes oxide. So N2O is called dinitrogen monoxide. NO2. Okay. I've got nitrogen again, but this time I only have 1. Now this is where I don't use mono on the first word. So just nitrogen. And then this time I have 2 oxygens. So dioxide. So nitrogen dioxide. F2. Watch out, I slipped in a few secret, tricky ones in here. F2, any element by itself is just called that element. That's called fluorine, not difluorine. Cl2O7. So again, chlorine and oxygen. 2 chlorines. So dichlorine. And then 7 oxygen. 7 is hepta, and then heptoxide. You would drop the A in this case. You wouldn't go heptoxide, it would be heptoxide. CBr4. Notice carbons in that group 4 where I said it does weird things, well, this is one of the other weird things it does. Carbon's a non-metal, so we treat it like such when we name molecular compounds. We get carbon, there's only one, so we just call it carbon, not monocarbon. Carbon, and then 4 bromines, tetrabromide. So carbon tetrabromide. CO2, something that's probably familiar to you. Carbon dioxide. Okay, so carbon dioxide. BaCl2. Again, trying to trick you here. Barium, that's a metal. Okay, so it's going to be named ionically. It's barium chloride, no dichloride. What happens inevitably is after students learn prefixes, they want to use them on everything, and you can't, okay? You gotta go, is it a metal or a non-metal? If it's a metal, you do the ionic charges and you use Roman numerals for the transition metals. If it's non-metals, then you can use the prefixes. Okay, so writing the formulas, don't overthink it. Okay, don't make it harder than it is. There's no charges to cancel out. Diphosphorus pentaoxide. Okay, so we've got phosphorus and the pentaoxide says oxygen. So diphosphorus, that means 2, and then penta means 5. So P2O5. Tetraiodine nonoxide. Okay, tetraiodine. So that's iodine, obviously. Tetra means 4. And then nonoxide, well, we've got that oxide, so oxygen. And nona means 9, so I4O9. Sulfur hexafluoride, okay, sulfur, and then hexafluoride. Fluorine and hex means 6. Nitrogen trioxide, Ni3. Carbon tetrahydride. Okay, hydride there may not be something you're used to seeing. Hydrogen, under rare circumstances, can have that "ide" ending. So carbon tetrahydride, tetra means 4, CH4. Phosphorus trifluoride. Phosphorus, and then trifluoride, that's F3. Aluminum chloride. Okay, you might want to say AlCl, but it doesn't work like that. Okay, aluminum is a metal. So again, trying to trick you here. Al plus 3 and chloride's a -1. So we need 3 of the chlorines. Okay, I snuck in one of those ionic ones there. So it's AlCl3. Okay, so, you know, to finish off your assignment here, that's what you're going to have to watch out for. Okay, your worksheet for this section does just cover molecular compounds, but worksheet 5, which has no lecture associated with it, just has all the examples mixed up together. So you're really going to have to show you know the rules for the different things. Okay, so just a summary to help you guys out. Ionic compounds have to have a net charge of 0. An "ide" ending generally indicates a binary compound. Okay, remember binary means 2. Ate or ite usually means you have a polyatomic ion that tends to have oxygen in it. Prefixes generally mean molecular. They're going to show you how many there are of each atom. That's what we just learned about right now. And then a Roman numeral after the name of the cation is the ionic charge of the cation. Right? And you want to be sure to use your golden sheet. Okay, again, you will not be able to use the golden sheet on the exam or any of the quizzes, but I will provide you with a list of polyatomic ions for your quiz. So when you're getting them and they're all mixed up, you need to remember that any element by itself is just named for that element. Okay, those are your diatomic elements or things like S8. Okay, then you have to look and see what it's made of. Okay, you have to see if it's a metal with a non-metal or two non-metals. Okay, because that's going to take you down two different paths. If it's a metal with a non-metal, okay, the next thing to ask yourself is if there is a transition metal. Okay, or a group 4. Or a group 4A metal. Okay, the next thing to make sure you look for is a polyatomic ion. And then from there you can name it. Okay, when you've got two nonmetals, you get to use prefixes. Okay, so those are your two naming systems, and you're going to have to be able to keep them straight. That's why I give you a whole page of mixed up practice on these. So practice, 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 and then you can go ahead and take your test and have your C for this unit.